Hi everyone, and welcome to this DCD talk entitled Meeting AI Demand with Flexible Power Infrastructure. I'm James Raddings, Digital Portfolio Lead here at DCD, and I'm joined by Joaquin Aguirre, who's Director of Strategic Portfolio Development over at PowerSecure. Thank you very much to PowerSecure for sponsoring this session as well. So great to be with you, Joaquin. Before we start, could you just introduce yourself a little bit, tell us about your role at PowerSecure, and also what are some of the challenges that you're seeing at the moment and helping data center customers solve?
So thank you for having me, James. Pleasure to be here and have a great discussion about PowerSecure and what are we seeing on the market today. So I've been with PowerSecure for over 10 years, and always on the renewable side of things. I have been wearing different roles within the company, but lately I have been really focused on how to solve power availability, resiliency, and speed to power, really, mainly for the data center market, where we're seeing a lot of a movement there, as you can imagine. And I've been dealing the energy storage side of things for over a decade now as well. So I love what we do today, really helping customers dealing with what is becoming the bottleneck in the industry today, which is power, right? It's not really energy anymore. It's really power, utilities, how to serve this new era of AI data centers.
Yeah. I mean, the backdrop of AI and, the huge amount of power, the big power challenges that you mentioned. So, AI workloads, they're placing unprecedented demands on data center infrastructure. I suppose delving in a little bit deeper to those power-related challenges, what are you hearing from across the landscape, hyperscalers, colos, and general developers right now?
So, great question. I will say we are not on an energy problem today. We are more as a power and timeline problem that the data center developers are facing today, and especially the bigger the data center gets, the bigger the problem gets in terms of how quick they can get utility power being delivered to them. So timelines in getting utility interconnection agreement being in place, transmission lines being upgraded, capacity being upgraded as well. So we are seeing a lot of challenges on which leads into being flexible in the design, right? On how we can provide power in the timeline the data center needs and the amount of they need in time of matter, right? Especially when you have workloads that are not standard IT load, flat loads. They are more AI load workloads. Are very spiky. They have very, very big power density. They have very high dynamic load fluctuation, very peaks and valleys. Have very fast ramp rates. So interconnection delays are being a big challenge today, right? In some cases, the power utilities are not there on those sites locations. So utility needs to install transmission line, create a substation to serve that load. So that typically takes a long time, takes 2, 3, 4 years. And data centers, they can't wait on that, right? They need power today. Matter of fact, there is a client of ours that was telling us a couple of weeks ago, we need power today. We need next year power. We can't wait 4 or 5, 7 years to get the power delivered to us. So we're being pushed in this industry to be creative, to try to come up with better ways to resolve these challenges and have power generation on site, right? So data centers are becoming their own self-sustained microgrids behind the meters, even way before they have a meter. So they can power up the data center and be operational until they get a utility being able to give power to them.
Yeah, and what you said as well encapsulates perfectly that misalignment with data centers needing to be built yesterday, but utility shortages, lengthy connection timelines and delays. So I suppose against those challenges, what are some of the strategies that operators are using to keep projects moving and delivered on time?
Oh, great question. So I think. But not really, I think what we are seeing and folks and developers are moving forward with, they're actually contracting project, developing project, and installing project is what we call bridge power, right? They're bridge power with microgrids. So they're becoming this with these grid constraints, not really on land or capital constraints anymore. They're deploying capital to develop a behind the meter power generation or a microgrid. That could be a combination between generators. It could be turbine fuel cells plus storage, right? So imagine just they're making self-sufficient data centers day one to be able to have the data center facility up and running way sooner than the utility can give the power. So going back to the concept of bridge power, right? And PowerSecure has a great solution for that, which is Bridge Plus is what we're calling it, which is a nat gas solution. So what it does is it gives you that prime power day one. And once utility comes in later, that asset doesn't become a stranded asset. It becomes a backup power solution. So imagine installing something day one today that you can use it for 24/7 for your power needs. And then once you have utility plug in, you just turn it off and bring it up only when there's an utility outage. So it's very flexible in that regards, and we're being very successful on that. So, and again, that's really, that helps developers to not phase projects, not making projects in phases, right? Following by the run rate with utility can give them. For example, we're seeing some folks today, they're saying, we can give you 20 megawatts today. Year 3, we can give you another 50. So they are building the data center following the utility phases, right? What this solution gives you, it's you want to install the 500 megawatt day one, and then use the power the utility gives you in those phases. So you just use utility as it comes, and then once you're ready to transfer all the load to the utility, you just transfer your prime power, your Bridge Plus solution to PowerSecure as a backup asset. So again, right? So what we're seeing on the, I guess to find out that thought, sorry, James, it's on-site generation plus storage is really what is helping developers to decouple from utility timelines, right? So speed to power is becoming a competitive advantage between these developers today more than actually the size of data centers.
Yeah. And you mentioned kind of almost like the lack of predictability. Like historically, many data center power architectures were designed around, relatively predictable IT loads. I suppose, what aspects of AI workloads are exposing the limitations of some of those conventional UPS and backup power systems?
Well, that's a great topic. So as we mentioned earlier, right, the AI loads are not, they break pretty much every concept that we used to have on data center loads, right? They're very spiky. They have these three, without getting too much into the weeds, but they have this different workload, being training, inference, fine tuning, and whatnot, depending where you are, is the type of load that you're going to have. So they could be very, very high transients, very low ramps, pretty big low ramps, and fast moving, unpredictable changes on that low profile. So that puts a lot of stress on the standard and typical, or let's say traditional data center design, where you will have utility power, you will have your distribution and backup generation infrastructure, and then you have your low voltage UPS where it's connected to your IT loads, right? And then the batteries on those UPSs are only used for when there is an outage, for right through. And then we have a longer outage, you ramp up your tier 2 or your tier 4 final diesel generators, right? So on these AI workloads, it's really not working well for that traditional design. So it's where energy storage is coming into the place on help or really to resolve those challenges that the AI is bringing to the table. So you need a battery that not only is a short duration, but really addresses the low ramps from AI. It also addresses the resiliency portion of it. Also resolve the efficiency losses by using just traditional backup generators against AI, or a stranded asset. Just imagine, right? Just put in a traditional backup generation, you will need to install a much bigger capacity than your average load, just because of those peaks, just to be able to withstand those fast ramp ups and ramp down of the load. So the legacy architectures are really designed for IT steady loads and no AI training clusters, really. So energy storage and PowerSecure, what we call the UBES, is really trying to resolve that, right? To give you a solution that you can just plug and play and use it for any IT load, standard predictable load, or also is ready for AI clusters, right?
Yeah.
So it's a microgrid. That's what the industry is moving towards, not just a standard backup gen plus UPS.
It sounds really good how, with the way that you're thinking and developing these products, how it really addresses that variability, which is such a defining characteristic of AI workloads. Shifting a little bit to energy storage, I know we've touched upon it a little bit. It's increasingly being discussed as, a lot more than just a backup solution. How do you see its role evolving within the broader data center power ecosystem, if you will?
A great question. Yeah. So what we're seeing today from customers, and really the challenges and the problem statement that they're bringing into the table when we talk to them, right? As energy storage it's not even becoming, it became already a necessity. It's a must, really, as part of the microgrid to deploy on data centers. And the reason of that is because the energy storage, it plays a key role on AI workloads, where you have, again, fast ramping loads, you have high variability and very unpredictable swings on those loads. So energy storage, what it does is it's really smooth out, filter those load transients to make utility more efficient, to make the generation, on-site generation, more efficient, or actually capable of supporting the load. And more around batteries, really any storage today, it's really acts as a shock absorber, is what they call it, right? And then you have different flavors. You're going to see in the industry, there is folks saying the super caps is really the solution, that the 2-hour, 4-hour battery is really the solution, or 1C or 1 hour battery or 30-minute battery is a solution. Even the combination of hybrid approach, super caps plus batteries is a solution. So very interesting to see on the industry today, all these different approaches to try to resolve this same problem statement. But something that we have been seeing is there is not really one solution. There's not only one solution that addresses this challenge, really. And everybody from their own perspective trying to push their own technology being the perfect solution, right? So for PowerSecure standpoint, what we try to do is try to combine them all and be flexible for our customers, right? So what we call UBES is uninterrupted battery energy storage system. If you think about it, it's a combination between a standalone energy storage and a UPS. Right? We combine the two technology into one, and then we are able to provide all the functionalities and advantages of a UPS, just traditional UPS, which is right through bleepless transition to backup generation. And also we can give you, the system gives you the AI smoothing capabilities that you need to. We can guarantee 100% filtration and smoothing of the AI, obviously depending on what kind of batteries. And going back to where I was mentioning before, is really depending on the customer and utility interconnection, if there is one, requirements, you may be well fit with just batteries, let's say a 30-minute battery, or well fit with 2-hour battery, but sometimes you don't have space for a 2-hour battery or a 4-hour battery, like a lithium-ion battery. So you need to be a little more creative. So we are very flexible on that in combining super caps today with lithium-ion batteries. So we give you pretty much a very cost-effective solution that tackles the AI plus give you the UPS capability and guarantees almost any utility requirement that you may have. Because and I'm double clicking on utility requirement because we're going to start seeing more and more utilities following what ERCOT did, the ERCOT 282 rule, which is mandating for every large electronic load to be able to ride through to a certain utility power quality transients that they may have. So energy storage now is going to start being a mandate to be able to ride through those scenarios. So it's very important for utilities as the data center get bigger. So every time there is not a voltage sag, the data center they don't disconnect. So to keep riding through that process. So we're not just really from a PowerSecure perspective. I like to say that we are not really just backing up the load. We are shaping it. Okay. We are shaping the load so utility can provide power, or on-site generation that can be efficient to provide power to the load.
Yeah. So, I mean, we've covered quite a lot today and how those approaches and different systems and products work in tandem. Looking ahead, how, as the industry is building the next generation of AI-ready facilities, what do you think will be the defining characteristics of a successful power strategy?
Oh, great question there. So, I'll say that it's already in motion. It's already changing. I think we're going to just see more and more and just being established. The batteries energy storage system is not going to be just thinking about backup power. It's going to be an active component into the system.
Yeah. Meaning
the energy storage is going to be used to shape the load, not just to back it up.
Yeah.
So it's going to be it's becoming, and it's going to be critical for every data center system, regardless if it's mostly if it's AI driven, but even IT, just flat IT load is going to be it's going to become more and more important to be an active component of the system. Again, you can think about load, not only AI load smoothing, but also grid support, right? Like Eric just mentioned, grid support or peak shaving, optimization of the on-site generation. So there's a lot of use case and value stack from a battery that's going to become more and more important as we move into the next generation on data centers. And that's why we believe in PowerSecure that the UBS, UPS plus energy storage combined is really the future here, because it can provide all those use cases just out of the box.
Sounds good. That's the way. That's certainly the way forward. I mean, well, thank you so much for your time today. It's been really good to speak to you, and thank you for everyone watching at home as well. If you've got any questions about anything that we've covered today, please do reach out to the team over at PowerSecure, and we'll tune in on Friday when we'll have another DCD talk. But thank you very much, and looking forward to seeing you on the next one.